You know the drill. You type a web address, smash the enter key, and bam, the page is just there. But what actually happens in that tiny fraction of a second? Welcome to this explainer, where we are going to completely dissect the anatomy of a web request. We're diving into the lightning-fast, totally invisible journey that literally powers your internet experience. Let's take Google.com for instance. Sure, we know the basics. You've got your protocol, like HTTPS, the domain name, and maybe a specific path. But behind the scenes, your browser suddenly has a monumental task on its hands. Out of the billions of connected devices out there, it has to instantly figure out where on earth is this exact website actually hosted. And here's the absolute kicker. This massive global scavenger hunt we're about to unpack, it almost always finishes in a microscopic time frame. We're talking well under 2 seconds. Everything we're about to discuss happens so ridiculously fast that it just feels like instant magic on our side of the screen. To really wrap our heads around this, let's use a real-world analogy. Navigating the web is exactly like ordering takeout from a super exclusive, incredibly fast restaurant. The URL you type, that's the restaurant's name. The DNS lookup is finding their street address. Connecting securely is making a private phone call. Your HTTP request is placing the actual order. The web server is the kitchen cooking it up. And the browser rendering is plating the food on your table. Keep that restaurant in mind because it's going to make this whole process click perfectly. Okay, so step 1, finding the address. We humans absolutely love simple, memorable names like Google.com, but computers, they only route data using numbers. So your browser quickly checks a DNS server. Think of it as the internet's massive high-speed phone book. To translate that friendly domain name into a strict IP address, something like 142.250.190.46. All right, IP address acquired. Now your browser has to actually make the call to the restaurant. But before we just start yelling out our order over an open line, it establishes a reliable, heavily encrypted connection. During what's called the TCP and TLS handshakes, the browser and server verify each other's identities, exchange complex encryption keys, and build a totally secure tunnel. This inevitable, rapid-fire negotiation is exactly why you see that reassuring little lock icon right there in your address bar. The secure line is finally open. Now your browser sends the actual HTTP request, officially asking the server to hand over the goods. It literally fires off a message that looks something like get/HTTP/1.1, which, if you don't speak code, is essentially just computer speak for, hey, please send me the homepage. And remember, this request isn't just some magic fairy dust floating in the ether. It is actual physical data traveling across the world. It jumps from your local Wi-Fi router, pushes through your internet service provider, bounces across multiple massive routers on the internet backbone, potentially hits a load balancer to manage traffic, and finally lands at the target web server.
Boom! Your request has arrived at the kitchen. This is the web server. It's running heavy-duty software like NGX, Apache, or maybe Node.js. Its entire job is to process the back-end business logic. It checks to authenticate exactly who you are, figures out what you're actually allowed to see, and starts prepping your specific order.
But wait, what if you ask for something highly dynamic, like your specific social media feed, or a shopping cart with your saved items? The server can't just guess that. It has to check the ingredient storage. And by that I mean databases like MySQL, PostgreSQL, or MongoDB. It rapidly runs queries to gather all the raw, personalized pieces of data needed to build your unique page. So the kitchen gathers all those raw ingredients, right? The server then bundles it all up into a neat response package. This package is stuffed with code, HTML, CSS, JavaScript, along with visual assets like images, videos, and JSON data. It grabs this entire package and ships it all the way back across the internet to your browser. Your food delivery has officially arrived. Now the browser has to plate the food, because let's face it, you can't just stare at raw code. The browser rapidly begins parsing that raw HTML it just received to build a structural foundation. We call this the document object model, or the DOM tree. Basically, it's translating lines of text into a structural map of visual elements that it actually knows how to display on your screen. Then, in a literal fraction of a second, CSS swoops in to dress up that structural foundation, dictating all the colors, the fonts, the spacing, the layout. But to make the page actually respond to your clicks and scrolls, JavaScript starts executing. That's what powers the smooth animations and dynamic API calls, often relying on modern frameworks like React or Vue to make the page truly come alive. Let's ground this for a second. Think about firing up a complex site like YouTube. First, DNS tracks down the servers, and that secure connection kicks in. Your browser requests the homepage, while Google's back-end databases furiously fetch your specific subscriptions and recommendations. Next, localized content delivery networks blast over those heavy video thumbnails. Finally, the React front-end renders the user interface, and JavaScript seamlessly loads that addictive infinite scroll. All of this happening instantly. To pull this whole shebang off without a hitch, the underlying architecture is just mind-bending. Big tech companies aren't using one server, they're utilizing thousands. They use CDNs to store massive files geographically close to your actual house for speed. Browsers aggressively cache files so they never have to download the same thing twice. And newer technologies like HTTP/3 are using cutting-edge protocols to shave those loading times down even further. Now, if you're building for the web, knowing this flow isn't just neat trivia. It's literally your master blueprint. Truly understanding this anatomy is absolutely essential for debugging tricky bottlenecks, optimizing site performance, designing airtight, secure APIs, and successfully scaling massive systems using today's modern tools. And here is the craziest part of all. That entire epic journey we just mapped out, that was basically just for the very first request. Loading a single modern web page today usually triggers dozens, sometimes hundreds, of additional unseen requests in the background. Pulling in custom fonts, fetching API data, loading advertising scripts and analytics, it can easily mean 50 to over 300 round trips are happening before you even have the chance to scroll. Thousands of miles crossed, encrypted handshakes validated, heavy databases queried, and complex DOM trees beautifully rendered. Literally all in the blink of an eye. So the next time you're staring at a blank search bar and you hit enter, ask yourself, are you just loading a web page, or are you commanding the most complex, perfectly synchronized machine ever built by humanity? It's pretty wild to think about.